There is a number floating around the technology news cycle that demands attention. It is $38 billion. This figure represents the rumored valuation of a secretive artificial intelligence venture linked to Jeff Bezos. Behind that number lies a $10 billion funding round. But if you look past the headlines, the real story is not about the money. It is about what that money is actually buying. It is about the transition from digital models to physical reality. To understand why a company would be valued at $38 billion, you have to look at the architecture required to build it. Standard artificial intelligence models today are largely software-based. They live on servers. They process text and images. They do not move physical objects. This new venture is reportedly betting on agentic computing. This means systems that can make decisions and execute actions without constant human intervention. The engineering challenge here is immense. It is not just about writing code. It is about managing the safety and reliability of machines that touch the real world. Think of the difference between a blueprint and a building. A blueprint is a set of instructions on paper. You can copy it infinitely without cost. A building requires concrete, steel, and labor. Once you pour the concrete, you cannot undo it without significant expense. This is the distinction between traditional software and agentic systems. Traditional software is digital. It is reversible. An agentic system that controls physical assets is like pouring concrete. It requires a level of precision and oversight that software alone cannot provide. The infrastructure must be robust enough to handle autonomous decision-making while maintaining strict safety protocols. Consider the operational side of this. In the world of machine learning operations, scaling is usually about handling more requests per second. But when you are talking about agentic systems managing physical assets, the scaling problem changes completely. You are no longer just routing data packets. You are coordinating robots, managing supply chains, and overseeing manufacturing lines. Every decision an agent makes has a physical consequence. If a model hallucinates in a chat interface, you get a weird answer. If a model hallucinates while controlling a robotic arm on a factory floor, you get a broken part or a safety incident. This requires a level of machine learning operations that is still being invented. The infrastructure must be robust enough to handle autonomous decision-making while maintaining strict safety protocols. Furthermore, the feedback loop changes. In traditional software, you update code and redeploy. In an agentic system interacting with physical machinery, you have to account for wear and tear, environmental changes, and unpredictable human interactions. The machine learning operations team has to monitor not just the software performance, but the physical state of the assets. This creates a massive data engineering burden. You need to ingest sensor data from the factory floor in real time and feed it back into the model so it can adjust its behavior. This is not a static model. It is a living system that learns from the physical world as it operates. This brings us to the leadership. Jeff Bezos is returning to an operational role. He is stepping in as a co-chief executive officer. This is a significant signal. It suggests that the venture needs more than just algorithmic research. It needs operational discipline. Bezos built Amazon on logistics. He understands the friction of moving physical goods. The gap between theoretical artificial intelligence capabilities and industrial-scale deployment is where this company is trying to win. By bringing an operational expert back to the helm, they are acknowledging that the hardest part of this venture is not training the model. It is deploying it in a way that is safe, efficient, and scalable. Investors are betting on what experts call the capability realization rate. This is a measure of how fast a company can turn its theoretical technology into actual economic output. A valuation of $38 billion implies that the market believes this company can bridge that gap faster than any competitor. They are acquiring agentic computing firms. They are building infrastructure. The ambition is to transform physical production. This moves the industry away from pure software valuation models. It anchors value in the ability to alter manufacturing and supply chains. There are engineering trade-offs here that are often overlooked. You cannot have full autonomy without some risk. You cannot have high speed without some chance of error. The safety features of these agentic systems must be baked into the core architecture, not added as an afterthought. This means the machine learning models are likely designed with constraints that limit their actions to safe parameters. It also means the monitoring systems must be incredibly sophisticated. They need to detect when an agent is about to deviate from a safe path and intervene automatically. This adds latency and complexity to the system. The engineering team is essentially building a safety net that moves at the speed of the machine itself. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.